Hello and welcome back to my channel. I am Upasana Taneja, and in today's video we are going to start two very important functions, tau n and sigma n. What is tau n and sigma n? One function that is phi n that we have already studied in our previous videos, okay, in detail, and we have studied that where do we use phi function, okay. So in today's video we will see how can we calculate these two functions, what are these two functions and how can we calculate these two functions, and then we will see some results on these functions, okay. So these some short tricks where how can we find tau n easily, okay, and then we will see some short tricks on modern algebra where can we use these functions tau n and sigma n, and we can calculate many things with these two functions, okay. So first of all we will start tau n. What is tau n? Suppose n is any positive integer, then tau n is number of positive divisors of n, okay. Like if you have 8, okay, you need to find number of positive divisors. You can easily say 1, 2, 4 and 8. We have 10, then you can easily say 1, 2, 5, 10. But in case of big numbers like we have 1000 or we have 10,000 and 500 something, it will be a big task to calculate their divisors, okay. So for calculating, why do we need divisors? We will see in those short tricks. Many times we need divisors, we need tau n. Why do we need? We will see, okay. But here first of all we will see how can we calculate tau n, okay. So for big numbers we need a formula that we can calculate easily. So suppose you have a number n, then what will you do? You will write that number in prime factorization form, okay. P raised to power k1, p2 raised to power k2 up to so on pn raised to power kn, okay. Like suppose you have n is equal to 18, okay. Then when you will prime factorize this, what you will do? 2 into 3 square, okay. That means p1 is 2 and p2 is 3, k1 is 1 and k2 is 2, okay. So after prime factorization, tau n will be, you don't need to see p1, p2 and pn, only just add 1 in power and multiply. k1 plus 1, k2 plus 2 up to so k2 plus 1 up to so on kn plus 1, okay, like this. So tau of 18 will be equal to, what is k1? K1 is 1 here, 1 plus 1, and what is k2? K2 is 2 here, 2 plus 1, that means 2 multiply 3, that means 6. So tau of 18 is 6. So we can easily calculate divisors of a number, positive number. These are positive divisors of a number, and this is the formula. Now we will see some results, okay, some results on tau n. Suppose you need to calculate tau n of a prime number. You have a prime number. You can easily tell. Suppose you have tau of 17, tau of 18, like, okay. So these are divisors, and every prime number has only two divisors, okay. Tau of 19, sorry, tau of 19, these are prime numbers. So every prime number has only two divisors. So tau, the result one is tau of p is equal to 2, okay. Whenever you will be having a prime number and you need to calculate divisor, the answer will be 2, where p is prime, okay. And next, second, when you need to calculate tau of p raised to power n, that always will be equal to n plus 1. Just add 1 in power whenever you have. Suppose you need to calculate tau of 16. Tau of 16 means tau of 2 raised to power 4. 2 is a prime, so this will be 5. 4 plus 1, okay. You need to calculate tau of 27. Tau of 27 means tau of 3 raised to power 3. That means 3 plus 1, 4, okay. So for p raised to power n, it will always be equal to n plus 1, okay. And third is tau of a multiply b. Suppose you have a very big number and when you can break it in two numbers, okay, and those two numbers are co-prime to each other, GCD of A and B is equal to 1, then tau of A and B is equal to tau of A into tau of B. Okay, so these were some results so that you can easily calculate tau n. Okay, and now we will see sigma n first, and then we will jump to some short tricks related to tau n and sigma n. So now we come to sigma n. What we have now, we have studied tau n, positive divisors of n are tau n. What is sigma n? If we add positive divisors of n, then we will get sigma n. Okay, like we had 18. Okay, 18 divisors of 18 were 1, 2, 3, 6, 9 and 18. Okay, we have these divisors of 18. So sigma of n is equal to tau of n is 6. Tau of n is 6. Okay, and sigma of n is equal to 1 plus 2 plus 3 plus 6 plus 9 plus 18. Okay, you can add these numbers. Okay, so that will be equal to sigma of n 5, 6, 12, 21, 29, 39. Okay, so sigma of 18 is 39. What is sigma of 18? 39. Why? Because sigma n is sum of positive divisors of n. But now again it comes that if we have a very big number, suppose we have sigma of 100 or we have sigma of 1000, then in those cases how will we calculate sigma n? So we should have a formula for sigma n. Okay, so what do we need to do? The same thing, just if you have a number n, prime factorize it and you will get p1 raised to power k1, p2 raised to power k2 up to so on pn raised to power kn. You will get this. Okay, then sigma n is equal to p1 raised to power k1 plus 1 minus 1 upon p1 minus 1. Okay, into p2 raised to power k2 plus 1 minus 1 upon p2 minus 1, the formula of sum. Okay, up to so on pr raised to power kr plus 1 minus 1 upon pr minus 1. Okay, so we were calculating sigma of 18 now. Okay, so we will see whether we get 39 or not. Like this is sigma of 18, we will write 18 is equal to 2 into 3 square. Okay, that means p1 is equal to 2, k1 is equal to 1. Okay, p2 is equal to 3 and k2 is equal to 2. Now you need to put these values in this formula. Sigma of 18 will be equal to p1 is 2, 2 raised to power k1 plus 1 means 2 raised to power 2 minus 1 upon p1 minus 1. p1 minus 1 means 2 minus 1, that is 1. Multiply p2 raised to power k2 plus 1, 3 raised to power k2 plus 1 means 3. Okay, minus 1 upon p2 minus 1, 3 minus 1 is 2. So this will be 4 minus 1, 3, multiply 27 minus 1, 26 by 2. Okay, so when you will cancel it, you will get 39. Okay, so this was 39 only, sigma of 18. So we can calculate by this formula as well. Sigma of 18 is 39. Okay, now like we saw some results on tau n, we will note some results on sigma n as well. Like first is, I can write here, first is result, sigma of p is always equal to 2 p plus 1. Sigma of p is always equal to p plus 1. Okay, where p is a prime. Second, sigma of a plus b is equal to sigma a into sigma b where GCD of A and B is 1. So you can easily, if you have a big number, you can split in two numbers and you can write like this. Okay. So now we will do some results. We have studied what is sigma n, what is tau n. Okay, we studied how can we easily calculate sigma n, tau n, and now we will see where can we use this sigma n and tau n in modern algebra to make things easy. Okay, so to leave the calculation, how to make things easy, how can we use these? Okay, so now we come to those short tricks. So this is the first short trick, that number of subgroups in a cyclic group of order n is tau n. If you need to calculate number of subgroups and you know that group is cyclic, okay, and you can check with many short tricks that group is cyclic or not, okay, that I will not discuss in this video. Suppose you have a group U50, okay, example, you have a group U50 and you need to calculate number of subgroups of U50. Number of subgroups of U50 means, what is U50? Is U50 cyclic? Yes, U50 is cyclic. You can watch my video in which I have shown 3 ways to calculate how can you see any UN group is cyclic or not. Okay, so we have discussed 3 methods there, so you can watch that video if you don't know. If you know U50 is cyclic, then we will proceed. Then we need to find number of subgroups. Okay, for that we should know order of U50, because number of elements in cyclic group of order n is tau n. Okay, so what is order of U50? Order of U50 is 550. Can you calculate 550? Yes, easily we can calculate 550. 5, if n is equal to p raised to power a, q raised to power b, r raised to power c up to so on, okay, then phi of n is n into 1 minus 1 by p, 1 minus 1 by q up to so on like this. So we have 50 here. 50 means 2 into 5 square. Okay, so that means we can write phi of 50 is equal to 50 into 1 minus 1 by 2, 1 minus 1 by 5. Okay, 50 into 1 by 2 into 4 by 5, 10, and this will be 5, and phi of 50 is 20. So order of U50 is 20. So number of subgroups is equal to, number of subgroups is tau 20. Okay, so this was not tough. If you know how can you calculate 550, how can you calculate tau 20? Okay, so it is very easy to calculate number of subgroups of U50. So it will be tau 20, and tau 20 will be equal to 20. You can prime factorize this 20. Okay, 2 2s are 4, 5. Okay, 2 2s are 4, 5s are 20. So this is 2, this is 1. So tau of 20 will be equal to 2 plus 1, 1 plus 1. 3 into 2, that is 6. So number of subgroups of U50 are 6. Now we come to second short trick. So this is the short trick for finding total number of subgroups of Dn. What is Dn group? Dihedral group. I have a video on this group. If you want to see in detail where we have rotations and reflections, you can see that video. That is very important. But in this video, in today's video, we are going to do short trick for finding total number of subgroups of Dn. Okay, subgroups mean if we have a group and subset of those groups which are groups itself are subgroups. Okay, and we need to find number of subgroups. So for Dn, the short trick is total number of subgroups of Dn are tau n plus sigma n. Okay, where what is tau n? We have studied that tau n is number of positive divisors of n. Number of positive divisors of n. And sigma n is equal to sum of all positive divisors of n. and we have studied this in detail, that what is sigma n and what is tau n. Okay. So for example, if we want to calculate subgroups of D8, total number of subgroups of D8, okay, that has cyclic and non-cyclic both subgroups, total number of subgroups. So n is 8 here for Dn, n is 8 here. So total number of subgroups will be equal to tau 8 plus sigma 8. Okay, what is tau 8? Tau 8, we have seen the formula also, that if n is equal to p1 raised to power k1, p2 raised to power k2 up to so on, pn raised to power kn, then how can you find k1 plus 1, k2 plus 1? This is the formula for tau n, and we have studied the formula for sigma n as well. Sigma n was equal to p1 raised to power k1 plus 1 minus 1 upon p1 minus 1, and similarly p2 and up to so on. Okay, we have studied this in detail. So here, what is tau 8? What is tau 8? Because 8 is a small number, so we can see like this only. Divisors are 1, 2, 4 and 8. So we have 4 divisors. That means tau 8 is equal to 4. Okay, and what is sigma 8? Sigma 8 means you can add these divisors, 1 plus 2 plus 4 plus 8. That means this will be equal to 15. Okay, so total number of subgroups, tau 8 plus sigma 8 is equal to 19. That means D8 has 19 subgroups, total subgroups. Okay, and next we come to total number of cyclic subgroups. Now we are seeing cyclic, only cyclic subgroups of Dn. Cyclic subgroups of Dn. Total numbers of subgroup are tau 8 plus sigma 8. But total number of cyclic subgroups, only cyclic, that will be equal to tau n plus n. Okay, this is equal to tau n plus n. So if we are seeing total cyclic subgroups of D8, cyclic subgroups of D8 is equal to tau 8 plus 8. Tau 8 is 4 and 8. Okay, this is 12. Tau 8 plus 8. So this is 12. So we have subgroup D8 has 12 cyclic subgroups and 19 total subgroups. Okay, so for any big number also you can try, and please tell me in comment section whether you were able to do it or not. Okay, if you have any doubt, then you can ask me in comment section, and then we will come to next short trick. So this is the short trick for number of non-isomorphic subgroups of cyclic group of order n. This is like the first short trick only, like we said number of subgroups of a cyclic group of order n, because whenever a group is cyclic, its all subgroups are cyclic, and it has only those subgroups which are its divisors. And divisors, how can we find divisors? Divisors we find by tau n only. So those all subgroups will be its divisor, order of those subgroups will be its divisors only. Okay, so whether we are finding subgroups or we are finding non-isomorphic subgroups, the number of those subgroups will be equal to divisors. Divisors means tau n. Okay, so number of non-isomorphic subgroups of Z15. If we have a group Z15, this is a group with respect to addition modulo 15. Okay, so if we are calculating number of non-isomorphic subgroups, the answer will be equal to tau 15. Tau 15 means tau of 3 into 5. Okay, when we have tau of A dot B is equal to tau of A, tau of B, if A and B are co-prime to each other, if their GCD is 1. Okay, so tau of 3 into 5 will be equal to tau of 3 into tau of 5. That means What is tau of 3 is always 2. Tau of p is always 2 because a prime has only 2 divisors. So this will be 2 and tau of 5 will always be 2. So this is 4. So Z15, because Z15 is cyclic, so number of non-isomorphic subgroups or number of subgroups will always be equal to 4. That is tau 15. Okay, so I hope you are getting what is subgroup, what is a group, and why do we use tau and why do we use subgroups and divisors and everything. Okay, so now we come to next short trick. So this short trick says that number of normal subgroups in a cyclic group of order n is tau n. Normal subgroup, what are normal subgroups? You can see in my videos. Okay, so here we are doing only short trick. So number of normal subgroups, if we have a cyclic group, okay, then number of normal subgroups is equal to tau n. As we know that any cyclic group has all normal subgroups only. Okay, so if you are calculating number of normal subgroups, whether you have z of 20 plus 20, okay, then number of normal subgroups tau 20, you have z of 18 plus 18, number of normal subgroups tau 18. Okay, like this only. So these were same short tricks, but when you get multiple choice questions, these helps a lot. Okay, so you need to concentrate on cyclic groups. I have a video where I have discussed some short tricks on modern algebra, and there also I have used this tau n and phi n functions, so you can watch that video also. We have 2 videos for short tricks of modern algebra for MCQs. So I hope you got this, what is tau n, what is sigma n, why do we use these functions, what is phi n, everything I am discussing nowadays. Un also, dn, many functions you can see on my channel. Okay, so if you are liking, then do subscribe to my channel and please press bell button so that you can get latest updates, and do visit my telegram channel Dr. Upasana Taneja, and please follow me on Facebook group you can join, and on Instagram Dr. Taneja. And thank you so much for watching and keep watching.